Okay, kiddos. So I know you miss me and I really miss making you videos. So I thought I'd try this, new thing where I give you a warm-up sort of thing to do. We're going to do a little practice. Hopefully you've looked at it and you've been able to do it and now you just want to check yourselves. So I'm going to work through this warm-up and then I'm going to give you an assignment where you have to go and fill this out and fill out the assignment and upload pictures of your work for some of them. Not all the questions will require pictures, but you will have to upload pictures that have to be a PDF file. So we're going to try this. We're going to see how this works. I'm trying to brainstorm ideas in order to give grades and figure out how to do tests and the like. I will probably have a Zoom session next week. We're going to certain schedule for first and third block on certain days and then second and fourth block on other days. So anyway, more information to come about all that. But hopefully you have the warm-up. Hopefully you've attempted it. This isn't going to be much good if you haven't tried to do anything. So let's just get started. So my first warm-up here, it's on series stuff. Let's keep this fresh. I know you've been doing review and calcmedic, but we're just trying to get everything all together here, a little bit at a time. So if we have some series, a sub n, and the sum of the series from 1 to infinity, right? And here is how we're defining a sub n. X minus 3 over 4, all to the n. Hopefully you recognize the type of series that is, but let's keep going here. It says find the center and the radius of convergence for that series. Now, hopefully you're not too rusty, but when you look at this right here, this is a power series because there's an X in there. And the center is just going to be the opposite of this right here, right? So that center should be easy to just identify from the problem. You shouldn't have to do any work. So the center is at 3. And then the radius of convergence. Well, in order to find that, the easiest way to do this is to think of the series, and hopefully that you realize it was geometric, right? And then otherwise you'd have to do that ratio test. But if you recognize that this is geometric, you can say, well, my R value is going to be this quantity right here. And I know to converge, it would have to be less than 1. So in order to find the center, we could do this. Now, 4 isn't going to give us a problem for absolute value, so we can take that out here, and we can have x minus 3 is less than 4. And that really is, the radius is 4. But how have we looked at how to solve that? Remember, we set this up as an inequality problem, and we'd solve x minus 3 is less than 4, and we'd solve x minus 3 is greater than negative 4. And so if we solve this, we get x is less than, what is that, 7, and x is greater than negative 1, right? And remember, in the past, to find the radius of the radius of convergence, we would say 7 minus negative 1 divided by 2, which would in turn be 4. So this value right here is really giving us that radius, okay? So we've answered that piece of the question. Let's keep going. So the next part, in part B, it says, given this right here, well, it says find this, and there's a 6 attached to the a sub n, and we want to find in when x equals 1. What is that even asking? Hopefully you realize it's asking you to find the sum of this series. And then hopefully on top of that, you remember that finding a sum can only work if it's geometric, or if it was telescoping. Those are the only ones that we can truly find the sum of. But that's what this means. When it just says find this, that's all it's asking you to do. All right, so let's think a little bit further. How are we going to do this? Well, let's figure out what this would be if we let x be 1 in this a sub n that we've been given. If we let x be 1, we've got 6 times, and if I put a 1 in there, isn't that going to be negative 2 over 4 to the n, which is the same thing as, what would that be, 6 times negative 1/2 to the n. Remember, this is geometric, so guess what, guys? That's our r value right there. This is going to be alternating, isn't it? Because that's negative. Well, remember, I can only sum a geometric series, and I need to know the first term, and then I need to know the r value. Well, r in this case is negative 1, which if we took the absolute value of that, that's less than 1, so we'd know this would converge. We couldn't find the sum if this didn't converge. Now, finding a sub 1, please be careful. There was a test question on a test or quiz or something you did, and this starts on 1. Well, you got to be careful that you use the 6 and you plug in a 1 here for n. That's making this negative 1/2 times 6. That's negative 3. Some of you ignored the fact of wherever something started on a question we had, and then also ignored that there was a number that you had to multiply by. All right, so here we go. We've got our first term. Now we just need to remember this formula. And if I don't remember this formula, I'm not going to get very far in finding the sum. But anyway, here we go. We would put the negative 3, because that's the first term, right, over 1 minus r. Well, that's 1 minus negative 1/2. So 1 plus 1/2, which is 3 divided by 3/2, which, what is that going to turn into? I'm sorry, that's negative 3 divided by 3/2. Is that going to turn into negative 2? All right, so it turns out the sum of this series, when we multiply 6 times the a sub n we were given in the beginning, turns into negative 2. Okay? All right, wonderful. Okay, so knowing that this series, now it's our series a sub n divided by n, has the same center and radius of convergence as the original a sub n. Find the interval of convergence for our new series here. Okay, well, what does that mean we have to do? Well, we're going to have to look at our new series, a sub n divided by n. What's that look like? That is, what is this? X minus 3 divided by 4 to the n. And then if we divide this by n, isn't that the same thing as multiplying? Let me write this out before I talk and say things incorrectly. Isn't that the same thing as multiplying by 1 over n if we divide by n? Okay, so that happens to be our new series. How's that for swell? All right, and so if we want to figure out the interval of convergence, remember that deals with our endpoints. And remember, we had endpoints up here when we did this. It would have been negative 1 to 7. And being that this is geometric, I'm not including those endpoints, because when you do, if you were to put those in to the series here, you're not going to get anything that converges at the endpoints, because remember, geometric series never converge at their endpoints. Well, now we've created something different down here, so we need to figure out what happens at those endpoints so that we know whether we need to include negative 1 or 7, meaning with a bracket or with a parenthesis. Okay, so that's our goal here. So what we want to do is we want to check x equals negative 1 in the new form series. So if we put a negative 1, we put a negative 1 in there for x, sorry. I have just created problems. If we put a negative 1 in there for x, remember testing your endpoints to infinity. If negative 1 in our series here is going to turn that into what? Negative 4 over 4. So that's negative 1 to the n times 1 over n. And we should know about this 1 over n. That's a special one. But if I put this negative 1 to the n in there, doesn't this turn into an alternating harmonic series? And we should know about harmonic series. Those are also P series, right? But if it's alternating, it's going to converge. Converges. And this is going to converge conditionally, but that doesn't really matter here. I'm just reminding us of that fact. This only converges if it alternates. So what that means at -1 is I can include that because this is the alternating harmonic series and it converges. So let's look at what happens if we use x equals 7. So n equals 1 to infinity. Now if I plug a 7 in here, now I have positive 4 over 4, so that's really 1 to the n. Well, that's really just a 1 times our 1 over n, and that's our harmonic series. And so this is the harmonic series that we remember diverges. Because we remember that this only converges if that alternates. So what that means is I would not include 7 as one of my endpoints. So this is, in fact, my interval of convergence. So you see what happens here. The center doesn't change, right? But the center and the radius, I'm sorry, doesn't change when we created this new series. But what happened is in my new series now, I can include the 7. I cannot include the 7 and I can include the -1 because I tested each endpoint to see if that converged at those endpoints. So I wanted to do something like this with you because this would be similar, I think, to different ways AP would ask questions like this. It just so happens this year I do not believe they're going to ask you for interval of convergence. And then some of our convergence tests we don't have to know, but we'll talk more about that as we continue on. But having seen this problem here, going through this warm-up, hopefully you were able to do that on your own. I am now going to put out there's going to be a little quiz. I guess I'm going to call it a quiz. I don't know, but I'm testing not only your knowledge on whether you can do this stuff and whether you can upload your work. So I will talk to you soon, I hope. Take care, guys.